Welcome back to this course, Introduction to Cloud, a presentation of Coding Boot Camps. This is session 5, Kubernetes. In this session, for our introduction, we're going to talk about what Kubernetes is and what it does. And we're going to talk about the architecture, so master components or master nodes, worker nodes, and additional services. So for our introduction here, first we'll do our recap. We had our overview of cloud computing, our varieties and services of cloud computing, including public, private, hybrid clouds, and our services are software as a service, infrastructure as a service, platform as a service. We discussed DevOps and Docker. So Kubernetes, or sometimes abbreviated as K8s, was a product that spun out of Google. Ultimately, it became an open source next-gen container-based scheduler designed to lessen the burden from managing such products, internal products as Borg and Omega. Kubernetes was designed from the ground up as a loosely coupled, containerized organization, running a collection of components centered around deploying, maintaining, and scaling applications. So it is a runtime environment. What does Kubernetes do? Well, Kubernetes is the Linux kernel of distributed systems that abstracts away the underlying hardware of the node and provides a uniform interface for applications to be both deployed and consumed from a shared pool of resources. So a little bit about the Kubernetes architecture. So there are master nodes, and they act as the primary control plane, and that is quite often a term in Kubernetes. So master nodes are the control plane for the Kubernetes product. Master nodes are responsible at a minimum for running the API server, scheduler, and the cluster controller. Commonly, they also manage the cluster state, cloud provider specific components, and other clustered essential services. Worker nodes of the Kubernetes cluster run and agents that manage the node itself, and they are tasked with executing workloads as designated by the master node. So we can see here a typical architecture. So we have our master node here. We have our user using a kubectl product that's connecting to the API server. We have a cloud server API. We have something called the etcd. We see our containerized runtime and our kubelets. So this is the master node, and it is connecting with the worker nodes. And in the worker nodes here, we have, again, our kubelet, our container runtimes, our kube proxy, and our pods. So just like these are named after pods of dolphins or pods of whales. The pods are where our applications are running. So we can see here, again, these two nodes are identical. They are load balanced with respect to the users. So some of the master components, run the API server, the etcd, or sometimes called etcd, the kube controller manager, the cloud controller manager, and the kube scheduler. So if we take a look here, we can see these services, the system services, the kubelet, and the container runtime, all interacting with the etcd and the API supervisor or API server. That is where the user is actually interfacing with the master node. And we can see here additional services such as the kube proxy, the scheduler, cloud API managers here, kube controllers. The Kube API server provides a straightforward facing REST interface into the control plane. So all clients, including nodes and users and applications, interact with Kubernetes strictly through the API server. It is the true core of Kubernetes, acting as the gatekeeper to the cluster by handling authentication, authorization, request validation, mutation, and admission control, in addition to being the front end to the backend data store. So the Kube server, again, provides a lot of the access to the product. The etcd acts as a cluster data store, so saving the state of certain of saving the date of the data store, providing a strong, consistent, and highly available key value store for a persistent cluster state. And again, it saves the state. It also saves the state of the cluster. The Kube Controller Manager is primarily a process that manages all core components and control loops. It monitors the state of the cluster via the API server and steers the cluster toward the desired state. So when it talks about a cluster here, if originally we configure three clustered state and one of those clusters goes offline, the state will be brought back to the desired state again, which is 3. So the API server will then spin up another or create another cluster to bring it back to the desired state. Cloud Controller Manager is that process that provides the cloud provider with specific knowledge and integration capabilities into the core control loop of Kubernetes, and controls include the node, the root, the service, and additional controller to handle persistent volume labels. The Kube Scheduler is a verbose, policy-rich engine that evaluates the workload and attempts to place it on a matching resource. So it is looking for a runtime that can actually manage the demands of the application and the demands of the users. The requirements can include such things as hardware requirements, affinity, and other custom resources. And node components. So the kubelet, the kube proxy, and the container runtime engine are the components of our worker nodes. So we can see here our container, again, the container runtime. We see the pods in the containers, our kube proxy, and our system services here. Again, these kube proxies and the kubelet are connecting back to the master node. The kubelet acts as a node agent responsible for managing our pod lifecycle on the host. Kubernetes understands YAML container manifests. So YAML is a specific markup language, and it can read from several resources such as file path, endpoints, etcd watch acting, and HTTP server mode, accepting container manifests over a simple API. The kube proxy manages the network rules on each node and performs connections for load balancing for Kubernetes clusters. So if there, again, is a state which requires several images or several pods to be running an application, it will be creating and make sure that that desired state of 3 or 4, whatever that desired state, is maintained. And available proxy modes, user space, IP tables, and IPVS. Our container runtime. So with respect to Kubernetes, a container runtime is a CRI, again, container runtime interface. Quite often it can be Docker. So there are others, we can see them here. And there are several containers that are compatible with Kubernetes. So Docker is one of them, and it probably is the most popular. There's CRIO, RKT, and we see here Kata and Vertlet. Additional services are kubedns, so that provides cluster-wide DNS services. So a lot of times there'll be DNS mapping and local host use within Kubernetes. So it's very important to track the DNS. The Heapster is a metrics controller for the Kubernetes cluster used by some resources such as the horizontal pod autoscaler. And quite often this is required for the dashboard metrics. And there also is a Kube dashboard, which is a web-based UI which displays gadgets and little viewlets with metrics on the Kubernetes environment. So in summary, we had our introduction and we discussed Kubernetes, what it is and what it does. And we discussed the architecture. We talked about the master node, the worker nodes, and the additional services. For live classes on Docker and Kubernetes, please consult your learning materials, and also live classes for mastering DevOps. Again, please consult your learning materials. All of these are great classes. And thank you for watching this video. This is our concluding video on the introduction to cloud. This has been a presentation of coding boot camps.